Right now, as you are watching this, a patch of ocean roughly the size of the continental United States has warmed by 2 full degrees Celsius above normal, crossing a threshold that scientists reserve for only the rarest climate events on record. The National Oceanic and Atmospheric Administration confirmed just over a month ago, on the 11th of June, that Earth had officially entered El Nino. Since then, it has not slowed down. It reached moderate strength weeks ahead of schedule, and as of an advisories issued just 5 days ago, on the 9th of July, forecasters now put the odds at 81% that by winter this event becomes what scientists call a super El Nino, a threshold crossed only a handful of times since 1950. This is not a single storm. It is not one hurricane or one heat wave. It is the atmospheric engine that sits behind almost every major weather pattern happening on the planet right now, and scientists studying it are being remarkably direct about what makes this particular one different from every super El Nino that has come before it. Today, we are going to break down exactly what is building in the Pacific, why scientists are treating it as the most dangerous storm pattern of the year, and what it actually means for the weather everywhere else on the planet. No hype, no exaggeration, just the data and what the actual experts are saying. Drop a comment and tell me where you live and whether your weather has already felt unusual this year. I read every one of these. If you want grounded breakdowns instead of panic headlines, subscribe. It is free, and a like helps this reach people who need to understand this before it fully develops, rather than after. Let us go for 5,000 likes on this one. Thank you. Now let us get into it. To understand why scientists are watching this so closely, you first need to understand what El Nino actually is. Under normal conditions, trade winds blow steadily from east to west across the tropical Pacific, pushing warm surface water toward Asia and allowing cooler water to rise up along the coast of South America. El Nino is what happens when those trade winds weaken or even reverse, allowing all of that warm water that would normally be piled up in the western Pacific to slosh back eastward instead, spreading across the central and eastern Pacific Ocean. This is not a rare event in itself. El Nino is part of a natural cycle called the El Nino Southern Oscillation that repeats every 2 to 7 years. What makes an event rare is its intensity. According to the World Climate Service, sea surface temperatures in the Nino 3.4 region of the Pacific, the specific patch of ocean scientists use to measure the strength of these events, have climbed about 3.6 degrees Fahrenheit, or 2 degrees Celsius, above average. That specific threshold is what separates an ordinary El Nino from what gets classified as a super El Nino. Here is why that distinction actually matters, rather than just being a label. Since 1950, only a handful of El Nino events have ever reached super El Nino strength, most notably in 1982 and 83, 1997 and 98, and 2015 and 16. Each of those events reorganized weather patterns across the entire globe simultaneously, triggering droughts in some regions, catastrophic flooding in others, and record-breaking heat nearly everywhere. The National Weather Service's advisory from the 9th of July gave this developing event an 81% chance of reaching that very strong classification sometime between October and December, alongside a 97% chance that the event persists all the way through early spring of next year. Even the more conservative forecasts circulating right now show peak temperatures for this event coming in well above the benchmark set by the 1982 to 1983 event, one of the most disruptive El Nino events ever documented. Now here is the part of this story that genuinely separates this event from every previous super El Nino, according to the scientists actually studying it. Every prior super El Nino in recorded history occurred against a cooler global baseline than the one we are sitting on right now. Global temperatures today are already running more than 1.4 degrees Celsius above pre-industrial levels. Dr. Daniel Swain, a climate scientist at the University of California Agriculture and Natural Resources, put it directly. He said that the world has never experienced a strong or very strong El Nino event layered on top of pre-existing global conditions, this warm planet, and that it would therefore not be surprising to see unprecedented global impacts by later this year into next year in terms of flooding, drought, and wildfire-related extremes. He went further, stating that either this year or next year, or possibly both, stand a good chance of setting a new global temperature record. That is not speculation from a headline writer. That is a specific, named climate scientist describing in his own words why this event is being treated differently than the ones before it. Let us talk mechanism for a moment, because this is where the actual danger comes from, rather than just a warm patch of ocean sitting somewhere, far away from most of the people watching this video. El Nino does not just warm one region. It fundamentally reorganizes what is called the Walker circulation, a massive loop of rising and sinking air that spans the entire tropical Pacific. Under El Nino conditions, air rises more strongly over the central and eastern Pacific, where the warm water has shifted to, and sinks more strongly over the western Pacific and the Indian Ocean, where it normally would have risen instead. That shift in where air rises and sinks does not stay contained to the tropics. It reaches upward and outward, altering both the Pacific jet stream and the polar jet stream, the same high-altitude steering currents we have covered in earlier breakdowns of extreme weather. A stronger, eastward-stretched Pacific jet stream tends to pull wetter, more active storm patterns into the western and southern United States, while other regions see their normal storm tracks pushed further away than usual, contributing to prolonged drought instead. This reorganization has extremely specific, well-documented downstream effects that scientists have tracked across previous El Nino cycles. Climate researchers analyzing wind shear patterns for this year's setup found below normal wind shear over the western and north-central United States, which, combined with the added atmospheric energy this event is injecting, raises the potential for severe storms in those regions, despite normally being somewhat protected by shear. At the same time, wind shear is running above normal across the southern United States, which, paired with the added energy from this event, is creating what analysts describe as a very supportive environment for severe weather across the southern half of the country. This is not a vague, generalized warning. It is a specific, regionally varying shift in where dangerous storms become more or less likely, driven directly by how this event is reorganizing the atmosphere above our heads. There is also a hurricane and typhoon dimension to this story that connects directly to storms we have covered before. El Nino years typically increase wind shear across the Atlantic and Caribbean, which usually suppresses the total number of hurricanes that form there, and this year's seasonal outlooks reflect exactly that, with forecasters calling for a below-average season in terms of raw storm counts. But suppressing the number of storms is not the same thing as suppressing their danger. According to Climate Central's tracking of Atlantic tropical cyclones, between 1980 and 2025, 190 Atlantic storms underwent rapid intensification, and nearly one quarter of those, 46 storms, did so at what scientists classify as an extreme rate, meaning sustained winds jumped by at least 58 miles per hour within a single 24-hour period. Last year alone, 2025, 4 separate Atlantic hurricanes rapidly intensified, and every single one of them hit that extreme threshold. The reason this matters for an El Nino year specifically is that while shear may suppress how many storms form in the first place, the ocean heat available to any storm that does manage to organize despite that shear keeps climbing, since El Nino years tend to coincide with globally elevated ocean temperatures. Fewer storms, but a real chance that the ones which do form behave more dangerously and unpredictably than their initial forecast track would suggest, precisely the same dynamic we discussed when we looked at what forecasters were watching in the Gulf earlier this month, and precisely the textbook conditions that allowed Super Typhoon Bavi to explode from a tropical depression to a Category 5 storm in a matter of days in the western Pacific just last week. It is worth being honest about the uncertainty here too, since overstating scientific certainty is exactly what erodes trust once people start comparing claims across different channels. Scientists studying El Nino are clear that its impacts depend heavily on strength, timing, and how it interacts with other separate climate patterns happening in the atmosphere and ocean at the same time, not on the mere fact that a very strong event is occurring. A member of the advisory group that develops NOAA's monthly forecasts specifically noted that very strong El Nino events being rare does not automatically mean more intense weather impacts every single time, since each event develops somewhat uniquely. What scientists are confident about is the direction and mechanism. Warmer oceans, reorganizing atmospheric circulation in ways that shift where storms, droughts, and heat extremes concentrate, layered this time onto a global baseline that has never coincided with an event this strong before. Here is what previous Super El Nino events actually produced, so you have a real reference point rather than an abstract warning. The 1997-98 event, still one of the most studied in climate science, triggered severe droughts across Indonesia and parts of Australia, catastrophic flooding across Peru and Ecuador, and contributed to widespread coral bleaching events across reef systems worldwide as ocean temperatures spiked. The 2015 to 2016 event drove similarly severe global disruption, and researchers have specifically noted that recent El Nino events, including the 2023 to 2024 episode, have consistently trended towards stronger intensity readings than events from earlier decades, a pattern one predictive model described as a gradual measurable increase over the past 4 decades of tracked data. If this year's event does reach Super El Nino classification, as the current 81% odds suggest, it would place 2026 alongside 2023 and 2024 in the company of only 5 of the strongest such events ever recorded. The 1982 to 1983 event is worth understanding in a bit more detail, because it remains the reference point scientists keep returning to when trying to explain just how disruptive a super El Nino can be. That event caught much of the scientific community by surprise at the time, since monitoring systems in the Pacific were far less developed than they are today, and it went on to cause an estimated $8 billion in damage globally, a staggering figure for the early 1980s, through a combination of flooding across the Americas, drought across Australia and parts of Africa, and disruption to fisheries off the coast of South America, as warm water displaced the nutrient-rich cold water that local fish populations depend on. Researchers have since built quantitative models specifically designed to identify super El Nino events using both local and global climate signals, introducing an index that assigns a numerical score to how closely current ocean and atmospheric conditions match historical super El Nino events. That index has been run retroactively against the 1982, 1997, and 2015 events and consistently identifies all three correctly. When researchers ran the same model forward using data available through 2022, it correctly flagged the 2023 to 2024 El Nino as a likely super El Nino before that event had even fully developed, and that event went on to become one of the 5 strongest ever recorded. Researchers tracking this index over the past 4 decades have also noted a gradual upward trend in its readings, meaning recent El Nino events, even ones that fall short of the super threshold, have been consistently registering stronger than events from earlier decades of the historical record. So what does all of this actually mean for you, wherever you are watching this from? If you live in the southern United States, the historical pattern suggests more active, wetter storm systems and a heightened risk of costly flooding events through the remainder of this year. If you live farther north, expect warmer than normal conditions and a heightened risk of the kind of prolonged heat domes we have covered in earlier videos, since a reorganized jet stream tends to produce exactly the kind of stalled, blocking weather patterns capable of trapping heat in place for extended periods. If you live somewhere prone to hurricanes or typhoons, do not let a below-average storm count forecast lull you into complacency, since the storms that do form this year are forming in an ocean carrying more heat energy than in an average year, raising the odds that any individual system that does organize could intensify faster and more unpredictably than its early forecast suggests. And regardless of where you live, this is a genuinely useful moment to know your region's own historical relationship with El Nino, since the pattern's effects vary dramatically by location, and your local National Weather Service or meteorological agency will have specific seasonal outlooks tailored to exactly where you are. If you have been watching our other recent breakdowns, this event is very likely the common thread running underneath all of them, even though none of those videos were framed around El Nino directly at the time. The stalled, record-breaking Omega Block, heat waves we walked through across Western Europe this summer, the unusually warm Gulf water and repositioned loop current we covered when discussing storm risk along the American coastline, and the textbook rapid intensification conditions that turned Super Typhoon Bavi into a Category 5 monster within days, all of them are consistent with exactly the kind of global atmospheric reorganization a strengthening El Nino produces. That does not mean El Nino directly caused any single one of those specific events on its own, since each of them had their own local ingredients and immediate triggers. It means this developing event is very plausibly the larger climate engine that has been making conditions favorable for that entire string of extreme weather to keep happening in the first place, across completely different oceans and continents within the very same several-week window. There is one more consequence of these events worth understanding, since it tends to get far less attention than the storms and heat waves, but carries enormous long-term stakes of its own. Ocean warming during a super El Nino does not just reshape weather on land. It stresses marine ecosystems directly, and coral reefs are especially vulnerable. During the 1997 to 1998 event, sustained ocean heat triggered coral bleaching across reef systems worldwide, a process where corals expel the algae living inside their tissue in response to heat stress, turning the coral white, and if the heat persists long enough, often killing it outright. Reefs take years or decades to recover from a severe bleaching event, if they recover at all, and a super El Nino arriving on top of oceans that are already carrying more background heat than during any previous such event raises real questions among marine scientists about how much additional stress already fragile reef systems can absorb this time around. The honest, grounded summary is this. What scientists have confirmed is not a single dangerous storm. It is a rapidly strengthening El Nino event, reaching moderate strength weeks ahead of schedule, with an 81% chance of becoming a super El Nino by winter, developing for the first time in recorded history on top of a global baseline already. More than 1.4 degrees Celsius warmer than pre-industrial levels. Every previous super El Nino reorganized weather patterns across the globe simultaneously. This one is doing that against a climate system that has never absorbed this much heat before a major El Nino event even began. Nobody studying this data is is claiming to know exactly how severe the downstream impacts will be in any specific location, and any channel telling you they can predict that with certainty is not being straight with you. What the data does tell us, with real source numbers rather than guesswork, is the trajectory, a climate pattern intensifying faster than forecasters initially expected, layered onto conditions that have simply never existed together before. We are going to keep tracking this as it develops through the rest of the year, sourced the same way we did today, straight from NOAA, the National Weather Service, and the climate scientists actually studying this event, not recycled headlines. Subscribe so you do not miss the updates as this event potentially crosses into Super El Nino territory later this year. And leave that comment below. Tell me where you are watching from and what this year's weather has actually felt like where you live, because behind every one of these forecasts is a farmer watching a rain gauge, a family deciding whether to prepare for a wildfire season, and a coastal community waiting to see whether the next storm that forms behaves the way the forecast says it should. 5,000 likes on this one. Let us go. See you in the next one.